Right, so you're recording, right?
Mm-hmm.
Okay. Okay. So let's do 1B. So again, they gave us two lines. We need to find the missing line. And since it's a right angle triangle, we can use Pythagoras theorem. Pythagoras theorem can be used to find missing lines and missing angles only for right angle triangles. Our first thing to do is write out our formula. What is the Pythagoras formula? Your hypotenuse squared is equal to the other two lines squared, and you sum them. So which line is our hypotenuse here?
KM.
KM, because that is opposite the little box, our right angle. So we now write KM squared is equal to any order for the other two lines. KL squared plus LM squared, right? Not just LM squared is equal to KL squared plus KM squared because you see 4 and 5 and you decide to add them on that side. It doesn't work like that. It's where the hypotenuse is. Everyone is clear on that?
Yes, miss.
Right. So now we put in 5, we start to fill in or substitute into what we know, substitute the values in. So Km would now be 5 squared is equal to KL would now be 4 squared, and we don't know what is LM, so we plus LM squared. Now we start to solve. We know that we are solving for LM squared, so we can send over the 4 and it will minus. So 5 squared minus 4 squared is equal to LM squared. That will be 25 minus 16 is equal to LM squared. That will be 9 is equal to LM squared, and we square root both of them so we can get LM. So that would be 3 centimeters is equal to LM. However, if you don't want to name the lines KM, KL, and LM, you can use the common letters. So what would be the name for the hypotenuse if we were using a common letter, someone?
L.
L. What would be the name for KL? Someone else.
M.
M. And what will be the name for LM?
K.
K. Right? And I want different persons to answer so I'll know that everyone is understanding. All right? So that's how and you could have labeled it L. So it would have been L squared is equal to M squared plus K squared. All right? I hope that you guys are seeing it a bit clearer now. So for 1C, we have triangle PQR. So we can call the lines PQ, PR, RP, our alphabetical order, QR. So we could call it those. What would be somebody who hasn't answered us yet? Tell me what, well, it's on the screen. So if we are labeling it common letters, I need someone who hasn't answered us yet. Tell me, how would you label Pythagoras theorem for common letters for this particular question? Remember, we are recording, so I don't want you all to take too long, please. Someone come to the forefront and answer the question, please.
Line QR would be P.
What's that?
Line QR would be P.
QR would be P, yes.
Line PR would be Q, and line QP would be R.
Thank you very much. Right, so the formula would now be what? If you're using common letters, what would you write the formula to be?
P squared plus Q squared plus R squared.
Very good, right? P squared is equal to Q squared plus R squared, because of course you need to figure out where your hypotenuse is and make your hypotenuse the subject of the formula, meaning the hypotenuse equal to the other two summed. So we watch the question, we wrote down the formula, and we start to substitute in values. They gave us the value for the hypotenuse, which is QR, or which is common P, whichever one you have it as. So we put in 13 squared is equal to the other two lines squared, and you add them. So we have 6 squared plus, we don't know what is PR, so we leave PR, and we are going to maneuver and solve for PR. So it'll be 13 squared, we send over the 6, minus 6 squared is equal to PR, and we work that out. 169 minus 36 is equal to PR squared. 133 is equal to PR squared. We root it. Why do we root? Why do we root at a particular point? Why do we root down there? Root the equations.
Anybody can answer.
Mm-hmm.
Because the PR or whatever the letters are is still squared.
Mm-hmm. So we root it to cancel out the squared, right? To get the actual value for PR, because we don't want PR squared, right? So that's why we root it. Does everyone understand?
Yes, ma'am.
Yes.
Any questions, anyone?
No, miss.
Okay, great. So number 3 now. I don't know if some of y'all probably would have watched this and was like, no, I don't know this. Anybody had that reaction?
Yes, me.
Yes, me.
But why? Why? I don't even think that it looks intimidating. I
And
could
then
clearly see that it's two triangles just back to back, right? Two right angle triangles, right?
yeah, I spent like 5 minutes just watching it, and then I realized, oh, they gave me these two angles, and I just define these two lines, and I just define that one, and when I find that one, I could use those two to find the next one.
Right. So yes, so it is, right? It's just two triangles sharing the same line, right? So once we work out BD, we can work out DC, because we have two lines for the other triangle, and we could use Pythagoras theorem to find the missing line, right? So once you work out BD, okay, again, someone who hasn't answered so far, using common letters, label the triangle on the left, triangle ABD. Using common letters, label that triangle for me, please.
Common A between B and D.
Mm-hmm.
C by AB and
Mm-hmm.
B by AD.
Right, so common. Right, so tell me what your formula would be for common letters for that triangle.
P squared equals T squared R.
S squared, what squared? So if you can't see it in your head, I suggest that you grab a quick paper and jot it down, right? Which will take you no more than 10 seconds. Are you ready? Hello?
Yes.
Do you have an answer?
No.
Why not? So you already labeled it. You already know where is D, where is B, where is A. So put that into the Pythagoras formula for me, please. What is it you don't understand to do?
B square, no, what's the thing? A square equals C square equals B space square.
A squared equals B squared equal what? What's your formula?
A square equal B square and B square.
So is A squared your hypotenuse?
Oh, sorry. B square is my hypotenuse.
So this is what I'm saying. You're all not taking your time and following, because we just did 3 examples, and for you to come and tell me that now, it means that you're still not settling and focusing on what you're supposed to do. And this is what I'm seeing in the homework. You have to be able to listen, and everyone I'm talking to, you'll have to be able to listen, follow examples, and be able to apply it to each question that you do. So please give me the proper formula for your Pythagoras theorem.
B square equals B square and A square.
Thank you very much. Right? Which would be 17 squared is equal to 15 squared plus BD squared, because we don't know what is BD squared, or plus A squared, whichever one you label it to be, and you maneuver and solve accordingly. Is anyone having questions on how to solve for the particular line, like when to send over, basically making stuff the subject of the formula? Is anyone having problems with that aspect?
No, miss.
No, miss.
Okay. So part B of number 3 was a bit tricky. Well, not tricky. They just asked you to give them something and you had to work out something before that. So where is line AC? We are seeing that it runs on the entire base of the triangle, right? From one end to the other end is AC, right? Yes?
Yes,
So what
miss.
would happen there is you need to, but we don't know the value of DC. So we cannot find AC if we don't know what is DC. Yeah? So they expected you to know to work out DC first, right? So that's why in the solutions you would see, you would realize I put find DC, because without DC we can't find AC. So we have to use Pythagoras theorem again to find DC. So someone else, please tell me, using common letters, what would be the formula for Pythagoras theorem? Yeah, go ahead.
All right. So it will be C squared equal to B squared plus D squared.
So what is C squared your hypotenuse?
No, it'll be D squared, sorry.
So what you all, is it that you all just
No,
blurt out
that
answers?
read it.
So take your time. If you have it on paper, everyone here is supposed to have the paper with their work in front of them. Label it on your diagram, and then when you're sure about what you're doing, repeat the answer. So go ahead.
Right. Yeah, say it over.
Yes,
Number
please.
1. All right, so it'll be D squared equal to B squared plus C squared, which is 13. Right. It will be
So we know that our hypotenuse there would be 13. So we
13
believe 13 squared is equal to,
is equal to 8 squared plus B squared.
right? So where did we get 8 from? We just worked out 8 in the previous question, right? BD is equal to 8. Yes, everyone?
Yes,
Yeah,
miss.
miss.
All
No.
right, great. And everything else is history after that. You know how to go down and solve for your formula. So once we get DC, we worked out DC to be 10.25. So of course we have to add the two parts to get the full line. So we'll add AD plus DC to get the total AC. Yes, so that will be 15 plus 10.5, which is 25.25. Any questions?
No, miss.
Are you guys sure?
Yes, miss.
Do you all need me to send you these solutions,
No.
or do you have it down already?
I have the rules on already, so I could work it out for myself.
Well, when I say send the solutions, I don't mean copy down the solutions. I expect you guys to still work it out, try and work it out, but just use the solutions as your reference to see if you are correct or not. Okay, so for let me see if I want to. Okay, so we had number 7, which was, I would say, the trickiest of them all. It required a bit more for finding the length of CD was the only difficult part in a way. But part A was just regular Pythagoras theorem, right? Um, so there's two triangles in one. I remember we were dealing with scalar triangles, a triangle that is just an enlargement of another triangle. Yes?
Yes, miss.
Right. So everyone remembers?
Miss, can you repeat the question, please?
So remember when we spoke about triangles that are a scalar of another triangle. For example, if you have two right angle triangles, one is a little smaller than the other. However, it's like two times, the lines are like twice the smaller one. So if you have a triangle that is like AO is 26, as you can see here, CO might be 52, right? So that means that it's 2 times AO. If you have OB as 24, OD can possibly be 48, meaning 2 times. So we remember we had to find the scalar, which is K, right? And the K, which is the scale factor, would tell us how much larger or how much smaller is one triangle to the other. So they expected you to use scalar to work out CD. Now for AB was just regular Pythagoras theorem using the small triangle. So we saw that in this shape here, there's two triangles, right? AOB and COD. Two triangles just cut into one diagram. Yes, everyone can see that?
Yes, Miss.
Yes, miss.
Right, so the smaller AOB and the larger COD. So they want us to find the length of AB, which is straightforward because we have two sides of the triangle. We have 26, 24, and we have to find the other part, and we know that it's a right angle triangle, so we can use Pythagoras theorem. Which line is the hypotenuse?
OC.
So we are dealing with a small triangle, right?
Oh, so there'll be OA.
Right. Do you know why we're dealing with this small triangle?
No.
Because like two lines.
And specifically they asked us for AB, right? And AB is the end of the first triangle. Yes?
Yeah, miss.
The line AB has nothing to do with the bigger triangle. That baseline will be CD. Yes?
Yes, miss.
Yes,
Yes.
everyone?
Yes, miss.
Right. So we use Pythagoras theorem. Which line is the hypotenuse? Which line is the hypotenuse for this small triangle, AOB?
AO.
AO. So we use AO squared is equal to OB squared plus AB squared, or AB squared plus OB squared, any order. And we maneuver, make AB the subject of the formula, root, and get our answer. Is that clear? Any questions here?
No questions, miss.
No, miss.
And for line CD, this is the part where we have to go and work out the scalar. So we need to figure out how much bigger is COD to AOB. So the line, what line would we use to compare OB to for the big triangle?
CD.
So
OB.
OB.
Uh-huh.
Where would that baseline be for the big triangle? Where?
BD.
So what's the full length of the big triangle?
It would be
So if OB is the baseline for the small triangle, what is the baseline for the big triangle?
18.
That's the triangle there. What part of BD is a triangle?
It's in a triangle.
What part of BD is a triangle? Anyone else, feel free to answer. If OB is the baseline for the small triangle, what is the baseline for the big triangle?
OD.
What's that, Cadiz?
OD.
OD. So remember, the big triangle is literally COD, right? So you can't just say BD is the baseline. The baseline will be from O to D. Yes?
Yes, miss.
Yes, miss.
All right, so if OA is the hypotenuse for the small triangle, what is the hypotenuse for the big triangle?
OC.
OC, right? And what would be the last line for the triangle, for the big triangle?
CD.
CD, right? So we are seeing the hypotenuse for the big triangle, the baseline for the big triangle, the height line for the big triangle, and we are seeing the hypotenuse for the small triangle, which is OA, the baseline for the small triangle, which is OB, and the height line for the small triangle, which is AB. Yes?
Yes, miss.
Right. So now we need to find out what is the scale factor for OD compared to OB. So what is the length of OD?
OD.
Mm-hmm.
It will be 42.
So it will be 24 plus 18, right? You add up the two parts to get the whole line, right? Now we need to put that length over the length of the small triangle, the base, which is how much?
Which is 24.
So 24 is for the length of the small triangle. So everyone is seeing 42 is the length for the OD, 24 is the length for OB. Any questions there?
No, miss.
No, miss.
All right. So for us to find the scalar factor, we just have to divide the two. We put the bigger line over the smaller line. So that will be 42 over 24. And the answer we will get is 1.75. So therefore, the scale factor for the big triangle is 1.75. Meaning, when you multiply the size of the smaller triangle by 1.75, you will get the bigger triangle. I know that we are accustomed seeing it increased by 2 or increased by 4, but it could also be increased by 1.75, right? One and a decimal number, right? So it means that K is 1.75 because 42 over 24 is 1.75. Any questions there?
No, miss.
Almost.
Okay, so how do we find the length of OC now? So if 24 by 24 multiplied by 1.74 is 42, so we got the whole length. How do we get the whole length of OC? 26 multiplied by the scale factor. What is the scale factor? 1.74. So it would be 26 multiplied by 1.74, which would be 45.5. So we used 26 multiplied by 1.75 to get the whole line of OC. We used 24 multiplied by 1.75, which would give us 42. Now we can use Pythagoras Theorem to work out what?
To work out CD.
To work out CD. Or who else can tell me what we can do? Instead of using Pythagoras Theorem, how did we find the lengths of the first two lines? Instead of using Pythagoras Theorem, what else can we do?
Miss, I kind of lost from this point.
Where, which point?
Here, where we start after we get 1.75.
So we got 1.75 because that's our scalar, right? So this will tell us how much our other lines are. So if you multiply 24 and
Miss.
this, y'all, this is not an, this is, my voice is not an ebook, right? An audio book, right? So I hope that everyone has a calculator and actually trying things while we're talking. So if you have your calculator and you multiply 24 by 1.75, what will you get?
You'll get 42.
42. And the line below is 42, right? 24 plus 18 is how much? 42, right?
Mm-hmm.
Right. So we got the length of OD. Now, how do we get the length of OC? We multiply OA by the same thing, 1.75, which is how much? Which is how much? So we are using OA
Miss,
to find the line of OC, and we use OB to find the length of OD. What else can we use to find the length of CD?
Miss, they could use AB to find the length of CD.
Very good. So we can say AB by what?
By 1.75.
AB by 1.75, the same thing that we use. We did 24 by 1.75, we did 26 by 1.75, and we can use AB by 1.75. And what is the value of AB?
10.
10, because we just worked it out in part A. So it will be 10 by 1.75, which is how much?
17.5.
17.5. So if we don't want to go that route, and let's say we want to practice our Pythagoras theorem, we can come down here and we will have 45.5 is the length of OC. 42 is our length of OD, and we can use Pythagoras theorem to work out the length of CD. Which line is the hypotenuse? Anyone but Nicola and someone else who already knows what they're doing. Which line is the hypotenuse in this question?
OC and OA.
See? What's that? So we're talking about the big triangle now, right? Which line is the hypotenuse?
OC.
OC, and OC is what length?
The 1.75 by the 26.
Which is how much?
45.5.
45.5. And what is the length of OD?
D.
OD, yeah.
D. Yeah, we did OD with the Yeah, OD is 1.75. No, I think that's OB.
1.75 is not the length of any line. 1.75 is the scalar.
Mhm.
What's the length of OD, anyone? Anyone? No, Nicola, I know that you know already. I want to hear what the others has to say. What's the length of OD?
OD is 42.
Right, because we said that a million times as well, right? OD is 42, because either you can say 24 plus 18, or you can say 24 multiplied by 1.75. Either one is fine for you to get 42. Yes?
Yes, miss.
All right. So now that we have OD and we have OC, we can figure out CD by using Pythagoras theorem. The formula would be what, using common letters. Who wants to label it using common letters for me? Tanisha, Tanisha, label the triangle. Kadis, label the triangle for me, please, using common letters.
OC is B, OD is, and CD is O.
CD is what?
I mean,
CD is what? I can't hear you.
O.
Oh, all right. So thank you using that. Please fill in for me the formula, Tanisha.
You can repeat the question, please.
So I want you to work out for me the Pythagoras theorem for the large triangle. What would it be? What's that? What's that?
It will be
So what is the value of common D, the line?
45.5 square equals 42 square and CD square.
So I know that everything is on a screen, and repeating it will just be to your detrimental if you just repeat it and you don't understand, right? I know that everything is on the screen, but I want to make sure that everyone understands what they are seeing on the screen and not just repeat what they are seeing on the screen. And you all know my radar is very high for knowing who is just repeating stuff, right? So do you understand what's happening there, what you just repeated?
Yes.
Are you sure?
Yes, I'm sure.
Right. So my hope would be now that as we went through these questions, and oh, by the way, and you will get the same answer, right? 17.5. My hope is now that if I send some Pythagoras questions for you guys to do with regards to finding missing angles or two triangles back to back, that you will be able to spot your hypotenuse and you would be able to use the proper formula, put your hypotenuse where it's supposed to be, put the other two lines where they are supposed to be, and work out the formula. Everyone should be a bit more comfortable to maneuver with the Pythagoras theorem now. Let me know.
Yes, miss, but I have one question. Why did we have to look for the scale factor?
Because they did not give us any information with regards to let me see if I could erase this. So this is what they gave us, right?
I said the reason why I asked because we find OD already, and we found OC. I think without.
No, without finding the scalar factor, you wouldn't have been able to find OC. Remember, it's because of your scalar factor you got to find OC.
Okay, yeah.
So that's why we had to find the scalar factor, because then we wouldn't know the length of our hypotenuse. Therefore, we would not be able to work out CD.
Okay.
Yeah?
Yes, miss.
Because and that's a very valid question she asked there. So we had the length of OD, but we only had the length of O what?
We had OB too.
But that OB is not for the large triangle. With regards to the large triangle, we had OD and we had OA, but we didn't have OC. Yeah, everyone?
Yes,
Miss.
And remember, we need at least 2 lines to find a missing line.
Okay, miss. So
Yeah.
if I was working out this question by myself, I would have put 18 on top 2 for AC.
Definitely can't do that because BD is a straight line. AC is a slanted line. Yeah?
Okay, yes, miss.
So we can't assume that AC is equal to BD because BD is straight, AC is slanted. They definitely can't be equal to each other just like that. Yes, she's asking a lot of valid questions as to what you would have assumed the question to be. Everybody's understanding what she's saying and what I am answering.
Yes, miss.
Right. So you cannot assume AC is equal to BD. How same way you cannot assume AB is equal to CD because they are different lengths. As we can see, CD is a little taller than AB. Yeah?
Yes, miss.
Yes, miss.
Right. So that's why we had to find the scalar, so we could have found the entire length of OC. And the scalar is pretty easy to find. All you do is put a long line over a shorter line. Put the longer line over the shorter line. Make sure it's the same parts of the triangle. So if we're using the base, we use OD over OB. If we had information for the line, the slanted line at the top, the hypotenuse, we could have used what? What over what?
If you wanted to find the hypotenuse,
If we wanted to find the scalar factor using the hypotenuse, what would we use? Remember, it's the length of the long line over the length of the shorter line. So what line would have been over what line?
the OD would have been over the OA.
OD would have been over what?
OA.
We have to use the same parts of the triangle. How is OA related to OD? The same lengths of the triangle. So let me explain that again. OB is related to OD because both of them are the base of each triangle. What 2 lines would be related again?
BD
BD
and AB.
How? How are they related? How are they related?
Miss, what do you mean by related though?
Right, and this is what I'm telling you all. The base of each triangle, the base, where's the base?
At the bottom.
OD.
At the bottom. So the bottom of the small triangle is related to the bottom of the larger triangle. So OD is the base of the large triangle.
Yeah. And
OB is the base of the small triangle. Yeah?
Yes, miss.
So the 2 hypotenuse of each triangle will be related as well. What is the hypotenuse of the small triangle?
OA.
26.
AO.
So
OA.
name them OA. And what is the hypotenuse of the large triangle?
OC.
Right, and those two are related because those two are the two hypotenuses of the triangles. What other two lines could be related?
AB and CD.
AB and CD, because those are the two heights of the two triangles. So if we are using scalar factors, we have to divide the length of the bigger one by the length of the smaller one. So you will say OD over OB, or you could say what else? Or you can say what else?
A,
Yeah, go ahead.
OA
OA,
over
OC?
OC.
not in that order. Larger one
OC
over
over
smaller one.
OA.
OC over OA.
OA.
And what else now?
And then you can say CD over AB.
Right. So whichever two lines you have information for, you can use that and find your scalar. So we only could have done that for OD and OB because that's the only two lines we had the information for. And remember, OD is not 18F. OD is 42 because you have to add up the both lines, the both parts. Yes?
Yes, Miss. Miss, next question.
Uh-huh.
I'm seeing the arrows, which means parallel. So AB and CD, won't it be the same thing?
Parallel doesn't mean equal. It just means
I was thinking
parallel. Huh?
That what I was thinking, if it would have been equal, and then I was like, no, equal is when it had the two straight lines.
Equal is straight lines, meaning a dash across the two lines, they are equivalent to each other, meaning they are equal. But parallel just means they are in the same direction and they are actually opposite each other. Yeah, so parallel does not mean equivalence. Uh-huh.
Okay.
Thanks.
Any questions? I like that. I like when you guys ask questions, it means that you are really trying to apply the concepts and learn it. Any questions, Kanis?
No.
Are you sure?
Yes.
Okay, so and with regards to the congruence, I don't think I should get into that. The solutions is very simple to tell you why they are congruent, right? Which lines are equal to which line, which angles are equal to which angles. So you could just simply read through that and you would be able to see it. Watch your question and read through it, and it will make sense to you.
Let's if you know further.
What's that?
If you know I was going to further, I was going and find everything to see if it would have come up to the same thing and then put yes, and it's like, wait.
They gave you all the information. Yeah, they gave you all the information already. Right, so I think that it was very necessary for me to come to this class because I don't know where you all would have been right now, right? But I hope that everyone has a better understanding of the theorem and would be able to apply it to questions in the correct manner moving forward. Yes.
Yes, miss.
Okay, and so Julie can stop recording now.